Hello, my name is Francesco, and today I will talk about Assignment 4. So, for part 1 of the video, the student will state his or her name. My name is Francesco, and I will verbally describe my contribution and demonstrate the project running. So, for the sake of time, I will start running the project right now because it takes like 5 minutes or something, maybe less. Okay, sweet. So now we see that the project is indeed running, and we're gonna wait for the final output in a little bit. In general, this project is a ray tracer, which is a program that simulates how light interacts with objects. In this case, it's a teapot. And it generates a 3D image pretty much. So it loads like a teapot model from an OBJ file, and it generates rays from a virtual camera into the scene, and it checks where these rays intersect with objects, and that determines what should be rendered, essentially. So now more specifically to the goal of the assignment, it was to add shadow calculations. Yeah, it's still running. It was to add shadow calculations, and that was done using shadow rays from each intersection point towards the light source to check if anything is blocking the light, essentially. So if an object is in the way, the pixel's color is made a little more dark, and that creates a realistic, quote-unquote, shadow effect. And this final implementation that we did, it includes, it's a combination of soft shadows, reflections, and multi-threading as well. And this improves both realism. I mean, it's not, it doesn't look like a perfect real teacup, but it's pretty good, and also improves performance. It makes the scene, even though it has no background or anything, I mean, no, like, realistic background, it looks more natural and efficient. So, still running. It should be done soon, but yeah, so for now I will start mentioning my contribution specifically to the code. So my contribution, in short, is includes setting up the camera's position, the camera's direction, and properly framing it in the scene. And then I implemented some soft shadows to make the lighting more realistic. I was able to do this by casting multiple shadow rays from each intersection point towards I would say slightly randomized light position, and this simulates an area light effect. And the reason why I did this is because it prevents harsh, unnatural shadows, and instead creates a smooth transition between light and dark areas. I mean, it's still not the same as a real teacup in real life, but it's pretty good. We're actually proud of the results. And yeah, it's all done to kind of achieve that realism, that's like view of realism in the rendering. And oh, perfect. So it ended, and sweet. Here you have the rendering, and yeah, it looks pretty good. You have like how the light source casts shadows, and yeah, it looks nice. It looks nice. We see there those reflections, and yeah, awesome. So now I'm gonna go more specifically to my part 2. I will read the Word doc and discuss line by line of what my code does. So this first line that's highlighted in yellow is a camera, initializing camera. So this, creates a camera in the scene. And the first parameter view, this part, says the camera's position and like the y, x, y, z value. And essentially what this means is that it is slightly elevated and placed forward in the 3D space. The x is 0. And then the second parameter is where the camera's looking, essentially. So in this case, it's slightly downwards, and it's looking into the scene pretty much, because it's -1. It's a negative z direction. And then the last parameter, 100, is the field of view, and it's in camera world, it means how wide the camera can see. And then if you go to this part in the bottom, which is also my contribution, we can see the soft shadows that I was talking about, the shadow calculation. So this method calculates how much shadow should be applied at a given point. And it does this by checking blocked from... it checks if that point is blocked from the light source. It loops through the different objects in the scene, and it determines if something is in the way, pretty much. So like over here in these 3 lines, we see that the shadow samples equals 20, which means that the program takes 20 different samples to simulate soft shadows. Then the second line, 0, is the counter that keeps track of how many samples are blocked by objects. So like essentially how many shadows, how much shadow to apply. And then we have the light radius, in which the light source is treated as slightly spread out instead of a single point, if that makes sense. And what this does is that it makes shadows softer rather than sharp. Then for this part, for this loop, it runs 20 times, and this is according to shadow samples. Shadow samples defines it. It randomly shifts the light source within a small radius, and like the radius is 0.3, and with this random offset, it generates a small variations in the light position, and this simulates the area light, so it makes the shadows appear more natural and soft rather than harsh or unrealistic, I would say. And then this last part, what it does is it slightly moves the light's position for each shadow test. And yeah, so those are my contributions for today, and I think that satisfies the requirement of the homework. Thank you so much.